the FDP, next gen AI techniques for biomedical data interpretation, under which we are going to discuss about some of the research points that what I was doing. Let us see what we can achieve from today's session. I hope that you will know few more things what I have found from my research works. Let us see what the topic is: the doctor's handwriting recognition for the healthcare. Now, for this, why this topic is relevant for us? Why this topic we will discuss? We just have a brief knowledge on this. Let us. The doctor's handwriting is very difficult to understand, as you all know. And we usually joke that the doctor's handwritten or doctor's prescription usually becomes understandable by doctors only. A general layman is unable to understand. Okay. So now, if we are planning such a thing where we can train a machine and train a model by the help of the doctor's prescription, doctor's written prescription documents, by the help of the doctor's prescription, and the model can help us in the healthcare domain while the doctor is not available physically. Can you imagine the situation where a patient is coming for treatment, but unfortunately at the same moment doctor is not available in the hospital? Due to the because doctor is human being after all, and he or she can take leaves, he or she can have vacations, he or she can take some rest also. So, but at the same moment, a patient can come to the hospital and can ask for some treatment. Now, how? That you all know. The Russian ritual was better when the texts are written in printed form and we are going to convert into a readable text format. But here our challenge is to convert the prescriptions. We have to do automated work. We have to do by the help of machines. At the same time, we need to ensure that accuracy and safety of the medical data entry. Because if it is wrong, if it is some errors are there, then it can hamper the life of particular patient, which is very dangerous. So this is also about the accuracy. It is that we can train a intelligent machine. Intelligent because it is doing the task of a human being, a doctor. It's not so easy task. We have to develop an intelligent model. The patient assistant without doctors, that one is told you, I told you. The patient assistant is possible without the physical availability of doctors. Due to the reason that our doctor is not available, but still we want to make survive to the particular patient. Where we have to use that concept where the doctors is not physically available. 24/7 healthcare is available. I told you that the doctor can take leaves, can have only holidays, can have vacations. So how can I help to the particular patient without the doctor's availability? So we need such a machine which can help 24/7 without taking a risk. Reduce dependency on traditional system. The fourth point is reduce dependency on traditional system. What exactly it means? We usually, when I go to a doctor, we have to take an appointment and we have to wait for a long queue. जब number आएगा तब जाएंगे. आपका number कब आएगा? So the number should come and then we are getting to get support from the doctors, which is usual support system. But now we are going to break over that. We have certain machine which is ready to help you at any point of time. So these are the real life applications that we are supposed to help to the society if our model is successfully working. Let us see how these models are going to be sorting out this kind of problems. Before jumping to the actual concept, we have to know about what kind of question is this, what are the divisions of categories of questions are available. Basically, there are two types of questions available. As per your knowledge, two types of questions are available. What are those? One is called as online question and this one is offline question. Our task is dealing with the second one, that is offline question. Now, what is the meaning of the online question? Let us understand. The online question is basically we have to write some content, some text on the digitized page. Digitized page you must have used when you are going to get a driving license. You are going to write a particular pad, digitized page, which is going to recognize what exactly written on the pad. But here, in case of offline, we don't have such kind of availability of digitized pad. Rather, we have a text document or a pen and paper. So from that pen and paper, what was written in an offline form, on a static form, my system will recognize that text as usually getting from a text. So this is the broad difference among the online and the offline. Online we have some standard inputs like the pen key pressures, the movement of pen, all these information are available. But in case of our offline system, we don't have those availability of the features. Now the task becomes very difficult to recognize text. This is the challenging task. Let us see how this offline research will help us to recognize the text written on text system or any kind of text documents written on a pen and paper. Issue is first one point that I already told you that the text is now not printed, rather it is written by human being, a handwritten text. A very complex, sometimes texts are connected to each other, sometimes texts are plastic in nature, so there are sometimes paper wings are slanted in nature, so the text is universal. So there are so many issues, so many challenges because it is written by hand, human being. Not exactly clearly written as we are getting from our printed text. As I told you, manual entry is not possible because there are plenty number of documents available, lakhs and crores of images available, so it is not possible to do human by human being manually. Now, third one is multilingual approach. Multilingual because nowadays in the rural areas of India, we have such doctors who usually write the prescription in the local language. In the local language, why? Because the people residing in the rural areas are not so well educated and they are unable to understand English language. So in that case, how that OCR will help them to get benefit out of this where the text is not written in English language. Rather, our research will focus not only in English but also at the same time it should focus on some regional languages of India such as Korea, Bengali, Hindi, like this, including English. This is the sole objective of our research project. This is one of the example of or sample of the prescription. How it looks like. The usually human written text are very complex in nature, and again it is documented. I hope nobody will do understand what written in the text. Very difficult to understand. Where is A, where is B, where is C? Very difficult to understand. Now, with this kind of restriction, I have to first find it out where the location, where my patient name is written, where the patient age and blood pressure is written, where the medicine being prescribed is written, where the doctor's signature is written or date is written. All these things I have to find it out from this prescription, and let us see how this prescription can be understood by the machine, and the machine can be trained to serve the society. These are so many kind of data sets available for prescription database. We are not going to discuss on this. Rather, I will show you that how to recognize the text which is written on a training paper or in an offline OCR format. Initially, I have to represent the text document in an image form by how? By performing the scanning. By performing the scanning from the text document. Then my model should be trained in such a way that scanning images can be converted into a text form, readable text form. Right. So before that, I have to apply so many kind of approaches, including the pre-processing, such as readable to biological person, such as removing the noise, removing the anomalies, removing the different kind of errors which are there in the papers, because papers may get cleared well because of time class. So these things I need to refilter. Then after I have to apply some filtration techniques. Then after apply for classification approaches by using some machine learning approach or deep learning approach. This is the overall process where we apply to get the text images to conversion from to text format, readable text format. The overall approach. So now this is not going to be done by us only. Like us, there are so many researchers, so many broad domains are working under this kind of work to get rid of this conversion from images to text form. Like the UDL, Universal Digital Library India, are the broadly some companies of working under the India also. We have in India this kind of organizations to conversion from images to text, OCR form. Similarly, Hyderabad also has a organization that is called Media Scanning Center, which will do the same kind of approaches, conversion from images to text form. Google also having some project Ocean. Yahoo, Microsoft, all companies are also working this kind of work for conversion from images to text form. Now, our objective is not so simple. It has so many challenges, so many complexities. What can be considered during this research work? Let us see. Our objective is to think about large number of class tables. I hope to understand about the class tables. The features, with these features, whether it's a dog, whether it's a cat, whether it's a rat, all these are called class tables. Database, in the right hand side, I usually have the class tables. Based on the features, we have some class tables. Now, my objective is to think about huge number of class tables. Why? Because we have the alphabets in English A to Z, a 26 number of levels, 26 number of classes. Is it 26 only? No. Because not only the uppercase, we may have lowercase alphabets. So 26 to 26 it will be 52. But is it 52 only? No. Because I have to add the numbers of 10 digits. Number of 0 to 9, 10 digits. So 25, 26, 26 and 10. It's all about 62 number of classes. 62 number of classes. It's about English. It's about English. Now I will talk about Korea or Bengali or Hindi. From all to Bengali. I have 50 number of characters. Yes or no? Around 48 to 50 number of characters. And again if I add the digits, 10 digits, again it will be 52, 60 number of characters. 60 number of classes. And again, if I think about the complex terms, structures, for a proper doctor, that means again I will add few more number of alphabets regarding the complex numbers, complex characters, composite characters. So for that again I have to add few more around 50. So around it is more than 100 number of classes. 100 number of classes. So classes, it is not about binary classification, it's about multi-class who is dealing with 100 number of classes. Not simple, that are very, very complex to. The impact of manuscript more than 100 number of authors. This doctor's format writing style is different than another doctor, and another doctor is different than another doctor. That means human beings all of are writing in different styles, different formats. That means my model should be able to recognize text written by 100 number of authors, 100 number of writers, more than 100 number of writers. In this world, anybody can write anything. So the model should be able to recognize the text written by multiple number of authors, 100 more than 100 number of authors. We have to reduce the required time. Also have to think of the time, because time is the most precious object we have in our life. So my model is taking very long time to execute, and it is going to recognize text with very long time. Nobody is going to use it. Nobody is going to use it because we don't have time. So hence we need such a model which has less time to execute, so that it can be appreciated, which can be taken acceptable by any of the users. We have to create such a robust feature assessment technique so that it can be usable by classifiers. Now, every classifiers are working in different kind of data. Every models have some different way of execution. So I have to design such a model, such a feature assessment technique which can be acceptable, which can be workable for any kind of models, any kind of classification techniques. So with this kind of requirements, I have to design a model. That is like OCR model, which is going to be very complex and very difficult to understand. For better understanding this approach work, I am going to show you one video clip which will help you to understand what exactly I am going to explain regarding the research work.
Picture this, a dimly lit hospital desk, cluttered with handwritten prescriptions, some crumpled, others smudged with ink. A weary pharmacist squints at a barely legible note, their expression filled with hesitation and concern. Now watch this dangerous ambiguity unfold.
So it is going to explain about an ambiguity. Ambiguity in terms of the medicine prescribed by the doctor. Doctors have written something about the particular patient, but unfortunately the pharmacy which is going to recognize the text written by the doctor is misunderstood. Now the medicine which is prescribed by the doctor and the pharmacy which is unable to understand and has given some wrong medicine, then what will happen? Obviously the patient will suffer. Obviously the patient will suffer. So this is going to explain by the story.
Same prescription reads as amoxicillin on one side, ampicillin on the other. Patients lying in hospital beds, doctors rushing down fluorescent lit corridors, monitors beeping, a rising sense of urgency and risk. But suddenly everything changes. A luminous digital overlay sweeps across that handwritten prescription. AI-powered OCR software scans the text in real time. The chaotic handwriting morphs into clean, structured digital data. The lighting warms and brightens, the environment transforms into calm efficiency. In this new reality, doctors and pharmacists collaborate seamlessly around glowing, futuristic screens. Digital data flows smoothly across displays. This is our future. Technology preventing errors and protecting lives. Safety, clarity, and trust through innovation.
So this is the whole story all about why we are motivated to do this kind of work. To reduce the effort not only for the doctors, to reduce the loss of life of patients by wrong interpretation of written text prescription by doctor and the pharmacy. This will save not only the patient, will also save time for both doctors and patients. With this objective, let us understand what about OCR. and what kind of approaches we usually perform under this OCR based upon the input provided. As I told you that we are basically focusing on the offline OCR. It is can performed by the help of two approaches. One is called isolated character and this is called word. We are recognize the whole word, we recognize the isolated or independent characters. My independent characters will have three approaches and my word recognition approach has also three basic approaches. My approach is based upon the word recognition will recognize the whole word at once. Sometimes the words are printed, sometimes the words are recursive means having color taken from cameras. Sometimes also written the text written by hand. At the same time, the isolated character also suffer from different inputs, such as one is that is reciprocated, where the individual characters are separately written by machine. Second is the recursive, based taken by the cameras from real world, and third is the independent characters, isolated character written by hand, written by human. So our focus to deal with this kind of approaches, where the text written by human beings and is handed. Either you can go for this word recognition from this word at once, or you can go for this isolated character. Our focus here for this session, I have just kept this part, a very small part, but let us understand what exactly we are going to explain under this kind of character recognition, where the characters are individually isolatedly written by human beings. The whole process goes through this kind of approaches with the first scan images that we may go for some pre-processing. As I just told you, we have to perform some pre-processing to remove the anomalies, remove the noises, perform some filtering approaches. Then we are going to segment it. Because the whole prescription comes with variations, with so many things are there. With the doctor's clinic name, doctor's name, doctor's timing of visit, doctor's medicine being prescribed, the patient. So many parts are there. You have to segment it. I have to find the appropriate line. I have to find the appropriate word. I have to find the appropriate character sentence. So this segmentation is very much essential. After that, we will go for the feature extracting features from the segmented images. Then we will apply the classification approach. Later, we may apply some post-processing techniques. Okay, one more thing. This is the baseline, which is essential. We cannot skip this kind of approaches, but these are parts which are written above the baseline are optional. Based upon the requirement, you can use it. So this post-processing, why it is essential? Why it is required? Sometimes what happens, suppose that I want to write a word like this, written as good. Okay, written as good. A human being, I can understand this, written as good. But when it is given to machine is understanding G, O, and next is, instead of O, machine is understand it is A. Just an example. And next is D. So machine told that it is written as G, O, then A, then D, which is obviously wrong word. But how the machine will again understand that what it has interpreted, it is wrong. Later on, this particular word will be again sent to the dictionary. It's a AI-based model. So it will send to the dictionary, and dictionary will able to identify those words recognized by the machine, whether it is correct or not. So it found that this word is not correct. Rather, have to find some correct word. So it will do some edit distance method to find out the same 4 character words which is very much similar to this and this correct one having presented in a dictionary. So it will do such of those words which are starting with G, having O, having A, and having D, or the 4 characters based upon the placement of those characters in the dictionary. Then we will search from the dictionary which very much close to this word G, O, A, D is available. Based on that, it is going to rectify that this A is misplaced, A is wrongly written. The distance from A to A in terms of not alphabetical order, in terms of shape and size. The distance from A to O is very closer, so there are chances that the A is wrongly written. Instead of A, it should be O. So in that case, rectify from GOAD to GOOD, which will be a correct one. So this is the requirement of post-processing after doing the task of classification. My next step is to post-processing, so that I can get the appropriate word from the dictionary which is correct one, which can be given as output from the model. So in case of keyboards, as already I told you, to remove the noises, perform the segmentations, all these things will perform under the processing task. Coming to the next one of the important word under this processing, that is the conversion from grayscale image to binary image. Shall I explain this conversion of grayscale to binary? If you yes, I should skip it. If you say I will explain it. No problem. You can tell me. So basically, an image can be represented in three ways. Can be represented in three ways. You are taking a photo from camera, you are writing some text on the pen and paper, and you are having some binary image. There are three variations of images. The images are in three ways. One is called as the one image is called as color image, which is basically RGB. The color image. First one is color image. Second one is what is the meaning of color image? It basically has three colors: red, green, and blue. Combination of all these three will give you a color image. Whatever photo taken from your camera is basically a color image. That is R component, G component, and D component. And all these R value will lie between 0 to 25, G also 0 to 25, and D also from 0 to 255. First point. Coming to second one. That is the second version of the image is called a grayscale image. Is called as grayscale image. What is the meaning of this? Here the pixels of each or every image are having only one value, and that value should lie in between 0 to 255. 0 is black, 255 is white. And if it is lying in between 0 to 255, it will give you some gray type of value. Towards 0 will give you higher type of black, and towards 255 will give you lighter version of black. It is called as a grayscale image. But the last one is a binary or black and white image. A binary or black and white image. Now here it has only two values for every pixel, either 1 or 0, either 0 or 255. 255 is equal to 1. Okay, full value, full complete value. Anyway, the binary value is basically two values, 1 and 0. I consider 1 and 0 over here. 1 means white, 0 means black. So why I am talking all these three values, three types of images over here? मैं क्यों बोल रहा? Why I am taking only these three types of values over here? Because our text image, look at this PPT also. Our text image is basically have two things. One, the text written by the pen, that is obviously black in color, and the background which is white. So why should I go for this RGB? Why should I go for this grayscale? Only the binary is sufficient for understanding a text written by a particular person. Got that point? So there is no need of going through all these three kinds of representations. Rather, the last one black and white is sufficient to understand the text written by a particular person. So we are going to convert the whole image into a binary one, into a black and white. So this approach of binarization, the approach of binarization will convert the grayscale image that is by 0 to 255. So 0 to 56. In total 256 gray levels, but values will add to 0 to 255. Will convert from binary to grayscale to binary, 0 and 1. That is the whole objective of whatever text is given and to convert it to binary form. Only having black and white. Another approach, one is called as thinning, another is called as edge test. Thinning, because it's a text written by a pen, so there is no need of thick line. Rather, only one pixel line is sufficient to represent the text line of the character. So it is thin version where only one line is there, only one pixel width is there. And what about the edge version? Basically, we are trying to show the age of every character, the age line of every character. This graphical features will help you to understand what about meaning of the spelling and the age detection approach. Why I am telling all these things? Because all these things are going to be useful after next approach. What I am going to explain about the extraction and the model building. Now coming to the second lesson. Now I have to go for isolated characters. Isolated characters means only individual independent characters. Instead of the whole paragraph, instead of the whole line, instead of the whole word, rather I consider only the individual characters. Because I am going to recognize the characters. So here, first of all, I have to convert a binary image and its field of skeleton images, as I just told you. Afterwards, I have to do the segmentation by giving a line which will divide the whole word into possible number of characters. Then I will get some individual characters. So now this segmentation is not only splitting the words into characters, rather it is going to segment the whole document into number of paragraphs, from whole paragraphs number of lines, from the whole lines number of words, and the whole words number of characters. The whole process is going to give you some isolated independent characters. We have so many definitions available for our training purpose to the model. We will discuss few of them. Whatever the database written here are all being used here for performing the model training task. Here the description about the data sets are written by the help of some tabular representation. We showed you the number of samples written here, resolution of each and every. So what is the resolution? The number of pixels present in the whole image, starting from the row 0 to column 0 to row and column n. The whole total number of size of pixels is called resolution. And which script is written? Some are English, some are Bangla, some are Odia, like this. We have performed our research work in all of these languages and all of these scripts. Some of them are having only digits, some of them are digits to the alphabet, some of the alphabets only. We have performed our model on all these different categories of data, so that we can say that our model is robust enough, our model is able to recognize the text present in any of the type of variations of categories. These are some of the samples we have collected from our data sets. If you have understood Bengali, I can say these are Bengali Bangla characters, or it is Hindi characters, and these are all Latin or English alphabets of number 3. And these are some printed font characters, okay? And these are Odia 5, and this is Bangla 5. Different samples being presented here to understand how your data set usually look like. Our model is going to recognize all these different kind of inputs given in data sets. We are mostly focusing on this isolated character recognition. Other than this, we can go for sparse putting, word recognition, we can go for scene text recognition. Rather in the research work, we can go for all these things, but here in the presentation, we have to focus on this first one, or isolated character recognition. As I told you, we are mostly focusing on those languages which are being used in India, including English. We have moved to Hindi, Bengali, and Odia. So, in some cases, 26 levels of characters, in which cases 52 characters are there. These are basically the class levels. We can have fixed or fixed number of characters. Digits possible, also alphabet also possible. So, mostly our focusing in addition to English, our emphasis is given to Indian regional languages like Bengali, Hindi, Bangla, and Odia. See? The first approach is what I have used in our research work. It's called a sliding window-based extraction technique. Now we got the segmented character images. Okay. After performing the segmentation and other pre-processing approaches, next we are going to get the features. We are not going to compile direct images. Rather, we are going to get the features from the images, and these features will be given to the model to train. Let us see how this call it similarly a sliding window based direction plate. Sliding window. The name is sufficient to understand. Some window is going to slide. Some window is some size of position which is going to move from the goal image starting point to ending point. Afterwards, it is performed or evaluated on different benchmark datasets. Benchmark means what? Those datasets are very popularly used, are available freely in our different sources like Kaggle, UPL, all these things. Afterwards, we have applied some similarity based approach. I will tell you, I will discuss all these approaches also. How we are going to perform some similarity. Similarity among a character to another character. The similarity is low means they are very much equal. The characters are very much equal to each other. Similarity is dissimilarity is more means dissimilarity more means that both the characters are not equal. They are different characters. Later on, the same approach is being converted into tabular matrix format. I will show you how we are going to get the features in tabular format, matrix format, so that it can be applicable, it can be implementable for different machine learning approaches, machine learning models. This is the whole block diagram of the approach. Starting with the first one, we have to provide some training and testing samples because all of these are images. So to get some training model, to first train the model, but I have some training samples. Afterwards, we will go for some testing our model, whether it is working perfectly or not. Also testing. Regarding testing, we can go for some kind of parameters like accuracy, precision, recall, just to check whether this model is working perfectly or not. We have applied so many people already for these things, binaries and thinning, implications. Okay. Later on, I am getting two kinds of features. One is called a string-based feature, and this is called a tabular feature. String-based feature is set of characters. String that we already learned in C program concept. String level input, and this tabular or matrix format, having number of rows and number of columns. Very tabular. Then again, training set will be applied for training purpose and testing set will be applied for testing purpose. Now, when the string-based data is given, a model, which is called as academicians model, will recognize the text. Whereas, when the data is being written in tabular format, in that case, the model will apply some machine learning approaches to recognize the text. It is all about the task that are going to perform in this model. The first one is the approach finds features from angular shape. Each and every character of English or any kind of alphabet, each and every character has some different kind of representation. A in which you are writing, B is not same, C is not same. So basically, our aim is to find the motion of the characters, the text control for each and every character. By moving a window, here in my case, it is the window of size C by 2. Window of size C by 2. So basically, if it is an image having some number of rows and columns, I am going to take a window of C by 2, and this window is going to move, maybe downward, maybe forward row wise. And when this window will move, accordingly it will extract the features from the image. And this image extracted features will be represented in two forms. One is string form and another is matrix form at the same time. Let's know about the algorithm what are used regarding this handling the features from the images. Basically, we are going to divide the whole image into two parts. One is called as top part and another is called bottom part. The whole image will be divided into two parts, upper part and the lower part. The window is going to move from top part first, then the next is the bottom part. When it ends in 1, yes. So when this window will move towards the image, when it finds a white, it will look after its adjacent cells. The same thing written here also. So whenever the value in between is finds a 1 or white, 1 is white. At that moment, it will find about the other adjacent. If it is again white, Accordingly, it will generate the code, unique code. So look at this. So whenever there is some byte, the cell, inner cell and its adjacent, at that point, based upon the moving of in one direction, up to down and left to right. Based on that, it forms ECH. Similarly, based upon the presentation of the white cell and the black crystals, the sliding window will produce some unique codes starting point to ending point. Based upon the upper half, based upon the lower half. I am producing two different kinds of unit codes from starting from the starting point to the first half and starting point to the second half. Okay, and it is going to give you some string type connection of ECH, EDH to test that. That means it is going to give you some string value, some set of string value like this. So here I am showing one character that is written 6 and it is going to give you some string values like this random values of unique codes. That one unique code is produced by the previous algorithm. Now this unique code, what we got from the upper, what we got from the lower is going to be different. Obviously because of different characters and different shapes and different shape structure. So that is why this value is going to be different for different alphabets. Based on this, we got some unique characters for upper, we got some unique characters for lower, for a particular alphabet, like as well as A. Similarly, we have for B, we have for C, for different characters we have different unique. The same has been applied on the testing source, applied for the testing set of. Then we are going to perform some editing algorithm. So we apply some editing algorithm. Now the editing algorithm will give you the distance across two different strings. It's a very common approach that you have already studied in your syllabus, digital analysis algorithm, that finding the distance. So this is going to give you some editing distance. The minimum editing distance means the similarity is high. Minimum editing is similarity high. The both assumption is that both characters will be same. So based on this strategy, it is going to give you some which character is more similar, and based on that I have to compare whether this result is collected is correct or not. So just I told you, we have to collect the additions from comparing of upper part from the training data and the testing data. Similarly, distance from the lower part of training data and testing data. And I will get some kind of value of upper data and some value of lower data. And again I am trying to average of upper value and lower value. And it will give you some result value, and out of that, which was the minimum one, because I know that minimum is similarity is high. Distance is low means similarity is high. It will give you the class level of respective edition value. So based on this, we have to again identify which model is performing well or not. Let's talk about the edition approach. It's the same. What I was studied, it will give you some string-based approach. Now the same has been repeated by the algorithm table approach. How? The model is explained basically with the same thing, but here the same approach, angular motion was shape test feature in tabular. Another feature technique which is called as CPD, center to page distance and center to edge feature, are the three different kinds of features and techniques by the help of which I am going to train the model based upon the AMS features only, based upon the AMS possibility feature only, based upon the AMS CPD and all these three kinds of features. And then again going to compare the accuracy or system recall achieved by the models. Mostly are focusing on accuracy over here. So the approach is very similar with the previous AMS string-based approach, but here only difference is that we are going to represent in tabular form. How this was to alter. Look at here. Again the window is going to move upper part and the bottom part. Okay. Again from top down, but whenever the unique code is being collected as like the string-based feature, here I already mentioned the whatever the possible number of strings can be coming from the moving of sliding window from top to bottom. And whenever the number of times these strings are touching, number of times the strings are coming, it just counts the occurrence of frequency. And based on that, it will mention here that how much time I got AB, how much time I got AC. Like this, I am going to mention the number of occurrence of each and every unit course for each and every class level of the character. So this is going to give you one that is string form, already told you, and this is another one where the same AMS feature based upon the stable. Now this can be implementable for what? This is the additional approach, and this can be implemented for your miscellaneous approach. Different models can be implemented. Now coming to the next approach, which is called center to text distance based sequences. Center to text distance. Each and every set of characters are different, as you all know, for any of the language, any of the script. Now I am going to calculate the distance from its center towards the text boundary. Based on this principle, we have derived the iteration technique which is called center to text distance. Let us see. Instead of going to this algorithm, I am showing some diagram later just so that it will help to understand better. Look at this. One of the images here, a shape like this 8 being here. I just found the center, wherever it will like it may be. And from the center, it takes boundary. This is one, this is another, like this is distance from center to the boundary of each of the text position. And in the assumption that all of this will give you some different values of this thing. Now, here we are trying to find the 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. 8 directions from the center. Okay. Now, each and every direction have been mentioned with some specific thing. The right side x direction, right side upper direction with y-axis, upper direction left side, and left side x-axis, and similarly for bottom. And all these things mentioned here, and for all these class tables, we have to calculate the distance value and its distance. And for this, what will be the possible class level? We have to mention this. This is all about the distance measure, where the center to text distance is measured for each and every character. And last one is center to age based distance. Center to age based distance. We have already learned about how to calculate the age or how to find the age of a particular text, and also the program. If the time permits, I will show you how to write a program for handling all this first element or age first element. I will show you all this in Python. Now, it is for one character for Hindi Gha, okay, and this Gha will be center again, but we are finding the distance towards the its age outer boundary, outer boundary. And we found some values of each and every position of distance, and obviously there are 8 number of values, 1, 2, 3, 4, 5, 6 for the up and down. So all these things after calculating, we are finding some features like this. For AMS, we have around 256 number of pixel value, and AMS is CTD, that is going giving 8 number of 264 number of values. AMS plus CTD plus CD will give me around 72 number of features. Now, building of the features will be done, completed. Now we are going to train our models. Let us see how much accuracy we are getting from all these kind of physical accepted models. The data sets are being used like this for in this research work. This is one of the samples taken from the academic data set. This is another one for taken for the character certificate, and these two are being used here as well as reducing function. These are taken from the computer, and these are taken from the computer. These are few regional languages such as Bangla, Hindi, Odia like this. These are few of the alphabet taken from the Bangla characters 9, Bangla character for, and C is the Bangla numeral 9, okay, and B is the Bangla numeral for. We say the Devanagari Hindi 9, no, and Devanagari Hindi character for. All these the model has been performed and tested. Finally, when my result is coming, we can see that the different algorithms, different models based upon different feature extraction models, extraction technique, and how much they have given the accuracy. On angular motion of field, models perform this kind of result 42, 83 like this, whereas our string-based approach gives the highest accuracy of 96.83 on every data. And these all string-based method performed can be applicable on string-based model. So this image capacity which is tabular, in this case this national models can work, but the string-based approach cannot work. And the values are not mentioned here. Similarly, the character 74 case, where I am getting results like this, percent imbalance, percent all results are getting this kind of value, whereas string-based method gives me the height. What I can say? Here our model, which is been designed, that is a string-based approach, is performing best, one of the very best approach to recognize the aggregate text. And graphically also being shown here, we can see that these models perform well with one, the proposed model, that is the string-based approach. Instead of the other baseline models, the string-based model performs well. Now, coming to the next approach, which is called a heterogeneous approach. Heterogeneous means what? The concept is that I don't know you, even I don't have seen you earlier, and I have not seen your text, how you are writing, but still I am able to understand what I have written. How this is possible? I have trained from my teachers, and my teachers were writing something else, and I already understood what my teacher is writing. But when I am coming to understand somebody else writing, I also feel it very difficult to understand. The idea is that we are human beings, and we have learned from our parents, learned from our class teachers, but we are able to understand what my friends is writing, to whom I have not seen earlier, what my other teachers writing, to whom I have not seen earlier. How is this possible? How our brain is being trained such that we can easily understand text written by any of the persons in this world. That is because of the concept of brain is written like this, it can perform heterogeneous experiment. Heterogeneous means I have trained with one particular person, but I can understand text with some other person with handwritten text. This is called heterogeneous experiment. So let us see my model, whatever we have studied in the string-based approach, is trained on artists and tested on analysts. We look at all the different data sets. Still, I can get able to recognize with some very good accuracies. Out of that, coming to this best accuracy, here the model is trained on Calvin 74K handwritten dataset and tested on Calvin 74K font characters. Both are different, both are completely different, and I am getting around 80% accuracy. Can you imagine how better it is, how much more it is getting result? Although it is not trained in same datasets, but still I am getting around 80% accuracy. Second factor is that we usually want to train the model with higher number of training sets and testing of a smaller number of testing sets. We usually do the training 80% of data and testing on how much? 20% data. Okay, we usually do this. 80% training करते हैं, 20% testing करते हैं. But look at this one. This model has trained on 7.8 hereditary and tested on 7.2 font, where the training set is only 550 and testing set is 10,160. Can you just imagine? The training height is only 5% and testing height is 25%. Completely reverse, completely opposite. Still, it is going to give you 80% of accuracy. 80% accuracy. So, how much robust is this model is? Similarly, when I reverse it, that means trained on character font and tested on 7% hand. Opposite, I am telling you 95 accuracy and testing with 5% of data. Still, I am getting it. It is much more robust. It shows that it is much more robust. It can work in any kind of environment. Now we have made a comparison among the accuracy that model got. Means one of the paper we have also mentioned in the reference list. They have got some kind of accuracy with homogeneous accuracy and heterogeneous accuracy. And my model, with the proposed model, performed very much well while it is under the heterogeneous accuracy. Heterogeneous model. What is that? It is trained on eminent dataset and tested on RD dataset. Trained on eminent dataset and tested on RD dataset, which is the case 2, this one. Okay. The previous existing models, CNN and SBM, will get around this kind of results, whereas our proposed model shows around 72.7% model, which is higher than the other existing papers. That is, our model performed very much well. May not be the homogeneous case. It is around between 96 with the other get already got 97. I agree with that. But in the case 2, where it is heterogeneous case, the model performed very well. Right? These are few more results we have got from the tabular format, that is AMS in tabular format, and also we are getting the merged accuracy. The angular portion says tabular format, CTD, tabular format, CD, tabular format. We have got around accuracy 88, 73, 71, but when I merge all these things, we are getting 94%. The accuracy increases. And it is for all other remaining data set also mentioned here. Okay, now next chapter is the how to recommend the ODI method. For this, I suggest we have this around 50% chapter. We can take a small bio break, 10 minutes, then we again join. should be filtered. So what kind of approaches we have applied to get our images so that we can enhance our quality of the result in terms of accuracy can be achieved just I am to show you by the help of some programs that are written in Python. Instead of going through the whole detail of the code what being used here, those things are mostly available to you. But I will just show you that what kind of output that I can get from this input that I want to show you. This is one program. This is one program for the conversion of a grayscale image to get the binary image. Now, what exactly binary image I already told you, but the thing is that in case of original image, my image is always grayscale, and usually we get from any kind of images. The pixel value lies from 0 to 255. In total, this number of values. So, providing input to a machine to train the code, where I am giving the input more than 255 or at least 256, it will take long time to execute. Instead of that, we can give a binary image as input, so that the input size will reduce and my time to execute will also increase. That's what I need to get from a model. So the grayscale image, where the image is intensity value 0 to 255, where the binary image only deals with the white and black, that is my 1 and 0. The 1 means white and 0 means black. That we need for the model to play. And here we apply also systematic analysis to binary image. Assume that we have a image where the intensity value lies into 0 to 255. What I convert? Wherever the value is less than 200, it should be black, and if it is more than 200, it should be white. Based on that, it is going to give the text image or the image in a binary 0 and 1. It is about where my background is white and the text is black. Okay. But one more approach is there. You can also use, what is that? That is inverted binary. That is inverted binary. The same text, now it is inverted. What is the meaning of that? The black is the boundary background and the white is the text. So choice is yours. In both the cases, the result will be same, but the result size is different. Otherwise, the meaning is same. That here by usually what happens? 1 is white, 0 is black. But now what is done here? The background becomes white, black, and the text becomes nothing else. Other than this, both of these meaning is same. Third is the age detection. Age detection basically between the external and inner boundary. External and inner boundary. As if the distance text being provided, that is going small r, and what I have done, we have done that is age and the age. It is not the approaches we have used in our previous techniques. Distance from center to age. See. So here, basically finding the age of those characters of text being provided to us. The inner boundary and the upper boundary, outside boundary. Now, when the text are written in text line, okay. Now I want to get the isolated characters independently. How it is possible to get the independent isolated characters without segmenting the characters from the whole lines of whole words? That is, the concept is called as bounding box. The concept is called as bounding box. Okay. So Python we have an approach. That is bounding box approach. That is bounding box approach basically shows you that the possible number of words or from what to characters. The boundary of each and every separated words to separated characters. Assume that here I and n is and I is separated. Select and also it we consider as a I is separated. This part is separate word and this dot is separate word, which is obviously the mistake is wrong. Basically, our intent is to show you that how this bounding box can similarly, you will apply the same boundary concept to get the segmented characters. Also, you can see that I don't know whether last time students are able to see or not. Each and every characters are being separated by this approach. That is, boundary box being filtered and it is trying to find the possible position of each and every characters. So from this, we can easily get the coordinates of each and every segmented character. And you can retrieve. Basically, it shows you the coordinate. From where we can easily get the x is equal to y is equal to and the width from the particular location from the particular bounding box. From where we can easily extract the part of the each and every words, that is the characters. Obviously, from what to character I want to segment. And finally, we are going to recognize the text written in a particular image. That is what we are intend to do here. After getting each and every characters individually by the bounding box concept, we are trying to find the, just for example, it's not being actually written, it's just for example, how we are going to recognize the text, because we are going to recognize the characters, then we are going to recognize the words as a whole. Then after will be applied for the what? Post procedure by the help of the dictionary. Whether these words are available or not. If it is not available, then what is the closest word to the particular same word? So that I can predict that instead of this word, the closest word is also possible to be recognized word. These are the recognized words given out from this whole sentence. This kind of programs are also very useful for writing your research work. Like if you are trying to do this kind of work in your research work, also you can use this kind of approaches as a program. Now again we will continue our previous talk where we was left out with the recognizing the ODI words or ODI characters. Now assume that in a rural area by a doctor which is very much familiar with the patient and is trying to write the prescription in some regional languages such as what in Korea. In that case, how the OCR will work perfectly to recognize the words which is written in ODI, prescription written in ODI. So in that case, let us see this particular approach where I use the one technique to extract the features from the ODI character set. Our task is to here. We have applied three kinds of association techniques. We will discuss one by one. A neural network, which whenever you use the neural network, it takes the input directly images as input and tries to find the reference result. Okay. But here we have designed the model, neural network model, instead of providing the whole image as input, rather it is providing the input in terms of features. The neural network it can easily convert the text images to features automatically. There is no need of specialized providing input to the features. But here we have supplied the feature extract features towards the neural network. Why I will tell you. Other than this, we have designed a database system where we have included the ODI compound characters. As of now, there was no such database system where the database of ODI characters should include the compound characters. But we have tried our best to provide some data set where we can provide the compound characters in ODI database system. Now, what kind of challenges we usually see in our ODI characters? So first of all the ODI characters are roundly symmetric. Although we are very familiar with ODI, that's why it is not difficult for us. But for a machine, we found that all the characters are roundingly, right? So this is one of the challenge for ODI characters. So many items are very identical, very similar to each other, right? There is no such fixed rule for modifiers. Sometimes modifiers are bottom of the character, sometimes modifiers are top of the character, sometimes modifiers are around the left hand side, right hand side. So there is no such rule, specified rule for writing the compound characters where the modifiers are present in a particular location. No, there is no such rule. That is why. So what to character segment is very difficult. What to character segment is very difficult. one character may look like another. The example is this one. You can see that the flipping of dog will give you thought. Although we are human beings, easy to understand, but not on the machine how it can recognize whether the character is flipped or not. So this more can give you thought when it is flipped. So the augmentation of the character is not possible while you are supplying this kind of media characters to the machine. The last one is sufficient benchmark data set are available. As I told you, only 3 data sets are available from Inaugural and Bhubaneswar and AICTE ATAL. Only these 3 data sets are available, and again they are not having compound characters in between. So that is why we made such motivated us to create a data set of having compound characters from ODR. Now look at these compound characters. As I told you that there is no such techniques to find out where the compound characters, the decomposed versions of characters are available. Maybe the person maybe off. And now when I decompose the compound characters in possible number of simple characters, it may give you some other characters. So when I decompose co or, it gives me co and c instead. It is long. The decompose of month will give you more address, one more line which is not in the data set, and also 0 or no, anything it means, which is also very difficult to understand. And does give you some different kind of more number of alphabets. Similarly for other characters also. The objective is to show you that the decomposition of the compound characters will give you multiple other characters. So decomposition is not solution to recognize the words in India. Right. So what I have to do? Only these 3 are available. We are trying our best to create a one data set that is being called Bhubaneswar. So that is India, where we have included some of the compound characters because the compound characters are not available in the previous data sets. There are only 3 data sets: AICTE ATAL and IDP. These are the 2 samples of the data sets provided here. Now, what you can see, the data sets available to IIT Kolkata, IIT Bhubaneswar, IIT Bhubaneswar. All these are having numerals. NIT Rourkela, IIT Bhubaneswar are having only characters. Okay, but here our Bhubaneswar is much more than that existing and having around 102 number of labels. Labels is what I have already told you. It is number of classes, number of types of categories we have in this. Some of the variable, some of the sizes or dimension are variable, some are categorized, some are specific. There is no such specification rules. Whereas we here in a different research incorporated all the samples into 64 by 64. Number of authors or writers here is around 150. And although the samples are very less in compared to the IIT Bhubaneswar, still it is variety of trying to our best to include variety of samples in the data. Our data set consisting of 10 number of classes for the digits, 50 number of basic characters, and few popular compound characters. One of the samples is given here, starting the digits, alphabets, basic characters, and some of the compound characters not being all shown here because of the space issue. Our model, which are going to train based upon these few features. Out of this, ALF and CPD only exist in the previous slide. And the last one is that is approach based height orientation gradient, which is new for you, will be discussed in current session. Now look at this diagram or this figure. For a given input sample, we have cropped the sample into size of 64 by 128 resolution. 64 by 128 resolution. Now again, this image divided into 32 number of zones or areas, where each area of size 8 by 8. So this is 64 by 128 some number of resolution. It will give you 8 into 4, and then followed by here I am moving a sliding window. In my previous lecture, what I just told you, there was the sliding window of G.I.E.T. I hope you remember. Here the window has been taken 2 by 2 sides. Because I am going to form a high correlation gradient based method to extract the features. So when I am taking a 2 by 2 window, my pixel positions are possibly can give you in this high format. How it is possible? Assume that my 4 cells of the 2 by 2 matrix, like denoted as A, B, C, D. Okay. One category is that when the cells like B and D having white, like this, lines and everything. Another one when the A and C are in white. Similarly, the third case where either it is straight line, it's a horizontal line. It's a horizontal line. So either BC can be white or AD can be white. Right, understand? And the fourth one case is a vertical line. Either the AD can be white or DC can be white. Anyone is possible. And the last one case where all these A, B, C, D are white. It's a set of 4 number of cells are having white. So these all type conditions may arise while the 2 by 2 window will move across the whole image. That is image of 64 by 128 resolution. Now out of this image we have this number of nodes, and 2 by 2 window will move across this first this cell, this complete cell. After completing this, we will go over this one. After completing this, we will go for 3. After completing this, we will go for 4. Right? And again, we will go for 5, 6 like this. We will move on the sliding window. Now, how can I know that the extracted features are coming from this 1 or 2 or 3 or 4? Because all these cases I have only mentioned the 5 number of categories of relation features. So for that, I have to use capital regions, and for each of the identified pixels I have to represent 5 different number of values. For 32 number regions, I will get around 160 number values. 160 number of values. Because ultimately I am getting only 5 kinds of pixels. 5 kinds of pixels from each of the zones. So for one zone I am getting 5 number of zones, 5 number of pixels, and for 32 number of regions I will get 32 5 that is 160 number of pixels. That means whatever the even it may be, whatever size it may be, I just crop into 64 or 124, 128 resolution, and finally I am going to get 160 number of pixels. Irrespective of the size of the input image size, you can only get a fixed number of pixel dimension, that is means 160. So from this, afterward, all the computed gradient frequencies are stored sequentially based on the zone numbers. First when 1 will come, then 2 will come, then 3 will come, like this up to 32 number of zones. Finally, 5 simple gradient types were introduced, including one with no gradient. That was the last one. This one. It is no gradient. No angular slope. Gradient is slope. The angle. So what is considered here? My AMS, which was discussed earlier, is 56 number of dimensions. CTD was having 8 number of dimensions because of 8 directional distance from center. And finally, the approach will give you 160 number of dimensions. In total, if I add, I will get this much number of dimensions. Now, what is the next step is to use the models, use the necessary models. So these are the input samples, training and product testing, the frequency approaches, and the AMS, CTD, and approaching features that I discussed in the previous slide. And apply some machine learning models, including one neural network. Now, instead of emphasizing all these machine learning models, I am going to discuss about this one, because we can see that the result found from the specialized neural network is bit more than the existing one, bit more than the existing machine learning approach. So, because neural network we can increase the number of layers, and based on that we can perform well. So why it is being named as precise neural network? As I told you, the neural network is able to take the input as direct images. But where you can see the time required to execute is more, because if an image, suppose that we have an image of size 200 by 200, okay, 200 or 200. The resolution is how much? Resolution is how much? कितना resolution इसका? 200 row by pixel, 200 column by pixel. Okay. Total resolution is how much? 200 into 200. Simple. Okay. 200 into 200. That is how much? This much. In a neural network, we are going to provide the whole image as input. Without thinking anything, we just image, we are just providing the input as image, as it is. So for this, we need input number of neurons to be how much? 40,000. We need 40,000 number of input neurons. So based on that, it's going to recognize what text written is this. So obviously, so if the input is 40,000, will it take more time? Or input is how much? 424 will take more time. Which one will take more time? Huh? Then one input where the input is given only 424. Another case, the same method, provided 40,000 is input. Which one will take more time? This one. Okay. So this one will take more time. Which one will we need? The model which is taking more time is better, or model which is taking less time is better? Less time is better. Very good. That is why this is the objective, to design such a model which will take less time. Because you don't have time, you are trying to design such a model which will take less time to execute. At the same time, it is going to give you better result. It is going to give you better result from the other machine learning algorithms. Although we see that in some cases these models are declining by the accuracy result with very limited amount of accuracy value, but still it is acceptable because of its execution time is very less compared to the other models. These are few other results being shown here, right? Including all the central precisions, AICTE, FOD, all these things combined, and result is shown here. In all these cases, we found that our model, specialized neural network, is performing very well when compared to other existing models. It is for IIT Bhubaneswar dataset. It is also for Supply Modes dataset, for digit dataset. It is for IIT Bhubaneswar, where digit is basic alphabets, okay, and Supply Modes digit is basic characters. And finally, the model which is designed by our different Bhubaneswar, which was 112 classes having digit, basic characters, and compound characters. In that case also, the neural network performs very well than the other machine learning model. Where only the input is only 424 number of features. Coming to this one, as I just told you, the traditional approach which takes the whole image input, which takes this much amount of time to execute. On the AICTE ATAL, it takes 76 seconds. IIT Bhubaneswar takes 70 seconds. Similar also takes 45 seconds. Whereas our business model, which only takes the 424, but as I told, only less inputs are given. Obviously, it takes less time to execute. Hence, required very less time, around 4 seconds, 3.5 seconds, 3 seconds, etc. And finally, we compare the result with the existing models in the literature and our proposed model, special literature. We found that somehow the accuracy is declining, as I told you. Accuracy is declining, 99, whereas we have achieved 1% decline. Still, in some cases 97, we have also reached 97. In some cases, accuracy is falling. Still, as far as the time is concerned, it takes the less time to execute, hence this approach is acceptable. Last one is, we have used 4 different feature learning extraction techniques to have our features, including AIMS, angular movement, just shown in the previous slide, See, center to text and center to age system, all this will give you 272, 424, this kind of size of dimensions. So, is there any other approach by the help of which, again, can we reduce the number of features? If it is so, then also we can reduce few more time. Yes or no? So, that is why our aim is to reduce the feature dimension by using some feature selection techniques, so that my existing type of model can be reduced. This thing already I told you, finding the aim is average one more criteria, that is aim. In some cases, what happens? The age version of the character samples are provided instead of the thin skeletal image. Instead of the thin skeleton, we have applied the age version. In some cases, the images of the text is not clear, not clearly visible. In that case, the age version of the image gives you more clarity on the images. So in that case, instead of taking the specialized image, we have taken a age version of the image to get the tabular form of features. Model usually takes binary image, and age text image, which take the done. And one thing that is included here, that is my feature selection. To select the appropriate features which will give me good accuracy as well as it can reduce the time. Then prediction generation, text generation, apply the algorithm to get it the predicted classes. We applied a concept that is called as minimum redundancy and maximum redundancy. Minimum redundancy and maximum relevance. Those sometimes what happens, we have a table, basically a feature matrix having some number of columns. Assume that we have the last class level, okay, and some of the feature values, that is one is date of birth, and another is the age. Two columns are there, one is date of birth and another is age. Don't you think these two values, feature age and dimension, are very much related to each other? Don't you think these two are redundant? Yes or no? These two are redundant. So from one, we can easily get the other value. There is no need of patient time between the record of patient. Then there is no need of keeping these two values. Either one of these can be removed. If you remove, then also your accuracy is not hampered, will not reduce. Can you understand? That is why I have to find out this kind of two features or this kind of features which are redundant. So the objective is to use the technique that is called as minimum redundancy and maximum relevance. Redundancy and relevance. The relevance towards the accuracy, towards the prediction class level. So based on that, this algorithm gives the importance of all these features. Importance towards the relevance, towards the accuracy. Importance, relevance towards the finding the accurate result, accurate class level. So based on that, it gives the precedence or the importance of all these features. I have to choose the best feature out of those. Assume that I have n number of features and I want to reduce to 10 number of features. By removing n minus 10 features, how can I remove? I cannot remove randomly. There should be some technique so that I can remove these features and I will keep the best feature out of them. So by the help of this, we will get such features which are very much relevant, and by the help of this importance value, by the help of this importance, these are the features and the importance value. We selected top 30 features, maybe equal to 100, equal to 10, and finally, the models have been designed to get the result. Such as some machine learning models being designed, and also the required time also mentioned here. So when it was dimension 272, how much accuracy was there, how much time was taken. Okay. At the same time, I have also represented the reduced dimension, the best 100 being chosen here. The best 100 being chosen here, then how much accuracy is there and how much time is taken. Also, in some of the cases, the accuracy is little low. 91.45, now it is around 273 number of liquid tankers. So what I can say that we have reduced the time. Although we have sacrificed, we have compromised with the accuracy somehow, but at the same time we are trying to reduce the time, required time. In all these cases, we have the result is shown here. Finally, I want to conclude that here is the AMS feature in steam form, AMS feature in Nebula form, the AE feature and the FOD feature. All these features are completely novel. Already we have done the pattern for this. This kind of approaches where I am going to get the features from the irrespective of the size of the dimension of the image we provide. Right. So these are very novel features being discussed here. One more contribution is that we have divided, we have done a development database, ODI database, having around 16,198 number of features, 100 number of samples, including the compound characters. In a future work, it is that we have performed the work only from segmented characters. Right? We have first divided the whole image into number of lines, line to words, then word to characters. Now the work only performed on some segmented characters. But the model is not able to recognize the whole word at once. The time is being taken or being used for dividing or splitting the words to characters. So if the word at once we recognize, then the splitting of the character time will be reduced. So that is why this is a future work that the whole word of page can be recognized at once instead of recognizing the characters only. The compound characters, what we included in the prepared ODI dataset, is only having two number of compound characters. In later on, we are trying to include two more data samples from the compound characters, so that the model, what we trained on the particular dataset can work in more better. Finally, we have observed that the accuracy is declining or reducing in some of the cases. So we will try to use some more advanced models by the help of which this accuracy can enhance and improve as well. This is all our future work. These are two references. These are two publications.
Please ask. I'm happy to share my knowledge.
For this session, now I request Dr. Chandan Kumar Kahikar and convener Sir Ayana to felicitate the chief guest.
କେବେ ନା ସନ୍ଧ୍ୟାବେଳେ କରୁଛୁ ମ୍ୟାଡ଼ାମଙ୍କ ପାଖକୁ ଇଏ ନକର ତାପରେ ହଁ ସନ୍ଧ୍ୟାବେଳେ ପଠେଇବ ଡ୍ରେସ୍ କେବେ